What's up, guys? It's Hanson. Working on these final videos. So today we're gonna work on systems of linear equations. Hopefully you got your packet, period. So let's go. All right, so systems of linear equations, we have three methods. You have graphing, which is obviously when you make a graph, and it could look something like that. If it has no solution because they're parallel, it could look something like this. If there's one solution because they intersect at some point, and it could look like this when you have exactly the same line on top of each other and it's infinitely many solutions. So those are the three types of solutions, and then it just matters how you get them. So graphing is one way. Substitution is another way. Substitution is when you take an x or a y and plug it into the other equation, solve for one variable, plug that back into the other one. And elimination is probably my personal favorite, is when you add the two equations together to cancel out a variable, so you need opposite variables. The types of solutions, no solution when you have parallel lines, which means you have the same slope, or infinitely many solutions when they are exactly the same line, same slope, same y-intercept. So this equation, number 24, says solve using the graphing method, but there's a problem. Negative 2x plus y equals 2 is not any way I can graph. It's not point slope form, it's not slope intercept form, so I need to solve. So what I'm gonna do is I'm gonna take this first equation, and I'm going to solve for y by adding 2x to both sides. And when I add 2x to both sides and I don't combine the 2 and the 2x because they're not like terms, I will get my y-intercept, which is my b, and my b is going to be 2. And I will get my m, which is my other 2, or 2 over 1. So I can graph that line by plotting a point at 2, and then using my slope to go up 2 and over 1, and then up 2 and over 1. And I can continue that. And then for my other one, I need to subtract x on both sides. As you can see there, it's not solved for y. And then I get negative 1 minus x. So I'm going to get my y-intercept of negative 1, and I'm going to get my m as negative 1. That's a negative 1 over 1x there. So I plot my point at negative 1. And then I go down 1 and over 1. And 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 obviously it's going to meet somewhere over here in quadrant 2. So I'm going to go up and over, up and over, up and over, up and over. And I can keep doing that forever and ever. I'm going to do it over here, down and over. And it looks like, wait, that's not where I meet. Here's where I meet. Right there. Right there. So then I'll get my ruler, which I currently don't have in my possession, so I'm going to use this local Racine newspaper. Oh. We're going to get this on there. Got a line.
Why does it have to be perfectly straight?
Why does lines have to be perfectly straight? Because if it's not perfectly straight, it's not going to accurately represent the constant rate of change, because lines are perfectly straight. If it's wiggly or squiggly, it's going to make it look differently. And if you're using it to make predictions, it's not going to be accurate. Is that good enough for you? Mm-hmm. Okay. Shout out Tay-Tay on the camera. So then we got to get the solution, which is where they intersect, and that's going to be negative 1 in the x and 0 in the y. So this ordered pair is where they meet, and that's the whole purpose of solving a solution, is where they meet. 25, algebraically means I did substitution or elimination, and I said the answer was 3, 0. How can you check that? Well, one, you can do the problem. Cierto, la puerta. You can solve it yourself, or you can just plug in x and y, knowing that 3 is your x and 0 is your y. You plug them into each equation and check to make sure it's balanced. I'll do the first one. So you're going to get 2 times 0 plus 4 times 3 equals 6. Do the math. You get 0. Oh no, this pen's dying. New pen. You get 0 plus 12 equals 6. Uh-oh. 12 equals 6 does not work. So because it doesn't work for the first equation, it doesn't matter if it works for the second equation. That order pair is not a solution because it doesn't hit both of those lines. So that would be wrong. Mr. Hanson's a dummy. Doesn't work. 26 is just a word problem. Willy Wonka and the Chocolate Factory is that movie. You're going to graph it, see if it's true or not. I ain't going to do that. 27, I will do that. Substitution method. This is an example of the most basic substitution method because you already have y by itself and you already have y by itself. So if something equals y and something else equals y, then those two things are equal to each other. So we set it up as 5x plus 15 equals 2x. And then we're just going to solve for x. We're going to get 15 equals negative 3x, divide by negative 3 on both sides. I really like this color. And we're going to get x equals negative 5. Now, we're not done because we need an ordered pair, and an ordered pair has an x and a y, but we do have the x. So to get the y, we're going to plug this into one of the original equations. We're going to get y equals 2 times negative 5, y equals negative 10, and that is the ordered pair where these two equations will intersect or where they'll be equal to. We're all about being equal. Some things ain't equal. All right, so we got a bunch of substitution problems. We got ones like this. Negative 2x minus 6y equals 18 and 10x minus y equals 6. These type of problems, you need to make sure that you solve for y or x first. So I'm going to look at the two equations, and I'm going to see which one's easier to solve for, and I'm going to pick this one. I can solve that for y pretty easily. It's just a negative y. So if I want to solve for a negative y, I'll subtract 10x on both sides, and 6 minus 10, close the door please. 6 minus 10x is not negative 4x. It's going to be 6 minus 10x. And then I'm going to divide everything by negative 1 or multiply by negative 1 to get a positive y equals negative 6 plus 10x. Congratulations, Mr. Hansen, you have y by itself. Then I'm going to walk this up into this equation. So I'm going to use a different color. We're going to go negative 2x. But I'm not going to write 6y. I'm going to write negative 6 times all that because that's what y really is. Y is negative 6 plus 10x. See, you got light bulb moments on camera. I love it. And we're going to solve for x now. Now that we solve for x, we can have x. And we can come back here, plug it in for y, and bam, we got our ordered pair. So we get negative 2x plus 36 because we're distributing. Negative 60x equals 18. This is just equation solving, and you guys are good at that by now, I hope. Negative 62x. Oh, this pen's dying. All my good pens are dying. Somebody buy me gel pens for next year. 18. We're going to subtract 36 on both sides. We're going to get negative 62x equals negative 18. Oh, my goodness. This is going to be messy. Did I do something wrong? No. Well, I'm not going to finish this problem because I don't feel like it right now. But x will be something, let's see, 9 over 31. Just because it's messy doesn't mean it's not the answer. But let's say this is right. I'm not confident anymore. But let's say it was. I would walk this up into x, and I'd get y equals negative 6 plus 10 times 9 over 31, which would be y equals negative 6 plus 90 over 31. Something like negative 3. So my answer would be something like, 0.25 negative 3. I don't know. Put it in Desmos, check it. All right. Whew, that was stressful. Let's take a breather. So substitution is a lot of work.
Oh, should go on you now?
Sure. So substitution is a lot of work. With systems, I like elimination, but you got to make sure you have opposite variables. So let's figure out how to do that, guys. Let's look at D.
Wait, let's see if this equals better.
This is my good side anyways.
Because your hand like...
Ah, you're smart. Okay, so here. Looking at my x's, looking at my y's, I don't have opposite variables yet. However, I can see that my y, one's positive, one's negative. So I'm going to ask myself, what number can I turn both of these into so when I add them together, the y's cancel out? See, I let Talia use my pens, and look at all these caps she lost. So I'm going to go ahead and say 6. 6 would work. So I'm going to turn this into something plus 6y equals something. And I'm going to turn the bottom equation into something minus 6y equals something. How can I do that? Well, I'm a mathematician, not a math magician. So I'm going to multiply this by 3. If I multiply everything by 3, I don't change the value of my equation. I just change how it looks. It's like getting $1 in back in quarters. It's still worth $1. So 4x times 3 is 12x. I did 2 times 3. And then I get 16 times 3 is 48. On the bottom, I got to multiply by 2. So I'm going to get 18x minus 6y equals 24. We're going to pause.
Do I end it or keep going?
Pause it. Stop it.
Yo, it's David John, Resident Evil King here. Check out my channel. You won't be disappointed.
Okay, thanks. Guys, we're back. So we were in the middle of doing elimination. We got it set up. So I'm going to add these equations together. And when I do that, I'm going to get a 30x 6y plus a negative 6y makes a 0y. They're gone. So they're bye-bye. And then we're going to get 48 plus 24, which is 72. What is up with all these nasty numbers? I'm sorry, guys. Whoever wrote this exam review is a mess.
You were nasty. Yeah, didn't you write this?
Shh.
Sorry.
Secret. So we're going to x equals... Oh, my goodness. X equals 72 over 30, which is equivalent to 2 and 1/15. Shout out Paige the Burper.
Don't put me in that. I already did, sorry.
And then we get, so I can reduce it by 2. We get 36 over 15. Can reduce it by 3 and get 12 over 5. That doesn't seem right. But it is. Okay, so there's my x. Now, this is just like substitution at this point. And again, these are messy numbers. Not my best work. I'm sorry. Maybe I can make up for it later. But I already have videos of this on my channel. Go look. They're way in the beginning. You would take this, plug it into this, say this equation, and go, 12 over 5. That really doesn't seem right. Whatever it is. All right, plus 2y, yeah, it is, equals 16. And then we go ahead and we do the math, and we get 48 over 5. Plus 2y equals 16. We continue to solve for y. And then you have your order pair, your x and your y, and you're done. So 28, I basically want you to be able to tell me how to do these 3 steps. You should be able to explain it. Math practice 3, we always talk about explaining our work. You got to be able to explain it, teach somebody hopefully, so that's for you to do there. What else we got in this beautiful review? And that's all we got for systems, guys. So basically, take what you know about linear equations, and use it to find the answer to a system of linear equations. So if you have 2 lines, you can have one solution. You can have parallel, which is no solution, or you can have infinitely many solutions. You can solve them via graphing, substitution, or elimination. Make sure your final answer is an order pair. That's where they're equal. That's where they meet. So hope you guys enjoyed the video. Leave a big thumbs up. Comment down if you have any other questions or requests. See you later.
Oops, I forgot to end.